Hello, everybody, and welcome to another Kinze Informational Service segment. My name is Phil Jennings.
My name is Brandon Venman.
And we're going to continue our conversation regarding classic planters, and in this case, classic planter row units. So 3000s, 5s. Guys, a lot of our row unit conversations are going to apply to even the older series, 2000 row units, even some of the newer series. But what we want to do in this segment is look at settings and adjustments for the field. How do we get maximum performance out of this row unit? So we're going to start clear up front and look at no-till options. It doesn't matter here, again, whether it's a Kinze, residue wheel and coulter combination, whether it's another brand out there. The whole intent is on the front side of this row unit is to clear the residue away, smooth the path for the row unit, as well as providing a little bit of tillage up front so we get a more uniform seed-to-soil contact at the end of this, right? Starting with residue management, they call them residue managers for a reason. They're meant to sweep the surface. They're not intended to be down in the soil profile and moving any dirt. If I see any soil buildup on the tooth, I realize we have a depth wheel here. We also have a depth stop. Let's make sure that we're only setting these things to sweep across the top. In all reality, if these are set correctly, they will only turn about 50% of the time. It's just going to kick the top residue out of the way. So what about the no-till coulter blade itself, Brandon?
Yep. So our no-till coulter blade is going to be that first point of entry into the soil that we have on this row unit here. Couple little maintenance tips for you guys. These blades are 16 inches in diameter new. Like Phil showed us earlier with our openers, that 14.5-inch diameter point is when we're going to want to look to replace these. Right. It's important to make sure our no-till coulters are set correctly. We want those set 1/8 of an inch to 1/4 of an inch above the bottom of our openers. All right. We don't want our no-till coulter to be setting the depth. We just want it to be that nice, crisp opening so our openers come in there and not get wedged up with any foreign material.
So we're looking at underneath the no-till coulter blade. The disc opener blade should be below that. Should be another 1/8 of an inch to 1/4 inch below. So the opener disc is always the final step in the base of that V opening. So we have the consistency of depth and consistency of seed placement for best yield potential.
Yep.
Okay. Now, looking directly above our no-till attachments, we keep coming back to and referencing the parallel arms. We talked about the differences between the standard 3000 and the new 05 series wear life improvements. But in between the parallel arms, we're going to deal with adjustment for downforce. We could have regular springs. We could have pneumatic, like is on this row unit. We could have the hydraulic or the true depth, all right? How do we know where to set our downforce? Just set it as heavy as it goes and drive? I mean, that'll cover everything, right?
Right.
Okay, but what are the risks? If we have too much downforce, what happens?
Yeah. So once we start to set our downforce too high, guys, we will start to see some seed wall compaction in our trench. Seed wall compaction leads to poor germination. The roots can't expand as far, which in the end is going to cost our customers more money.
What about the wear on the mechanical components?
Yep. Yeah, all that extra force, guys, if you think about it, if we're applying a lot of downforce here, it's a lot of stress on our lower parallel arms. We will start to see these egg out faster, and we will start to see wear and tear on our shank itself.
So anytime we have adjustment in this capacity, spring type adjustment, airbag adjustment, even the hydraulics, we want to have the least amount possible to get the job done. So how do we check it? Guys, set the planter in the ground and plant ahead for a distance. Leave the planter in the ground and stop and get out. What we're looking for is we're looking for contact between the bottom of this gauge wheel tire and the soil surface. That means I'm going to whatever depth I have set, and I shouldn't be able to move that tire. It should be solid against the ground. It's a real quick way. A lot of times guys will say they go back out and they kick the tires. They make sure that they're firmly in position. It's a good indication we have appropriate downforce set. All right. We've already talked through in the previous video about setting the clearances on your disc opener blades, setting the clearance of that tire to the blade of our gauge wheel. We need to talk about depth. Guys, depth is a matter of choice as the operator. As we pull the depth control handle down, we're going deeper. And as we walk this depth control handle one notch at a time, it's approximately 1/4 of an inch of depth change. If I go a notch on either side in one movement, I'm taking about a 1/2 inch of change in that, so deeper or shallower. Depth control sets that. We should have a uniform. We know that we've got the downforce set correctly, and we get to that point where we need to close that seed trench up. So we're looking at the closing wheel assemblies. Guys, know that there are several different options here. This particular row unit is going to give us the ability to take a look at a cast closing wheel, very popular no-till applications. We have our standard rubber V closing wheel. We're not showing in this case a spiked plastic, but that is by far our most popular here at Kinze. So gauge wheel or closing wheel choices, guys. There's also 2 locations to mount the wheels in this arm. So our Kinze recommendation is for a solid wheel like the cast or the rubber V, we're going to stagger those wheels. And whether left side's forward or right side's forward really doesn't matter. But what the stagger is doing is it relieves a pinch point so that as I get a root ball or a small stone, form material, instead of coming through and locking and potentially dragging these closing wheels, we're going to let that walk on through. Now, in the case of the spiked closing wheels, for the action of those spiked wheels to be most effective, we are going to recommend that those are set directly opposed from one another. And regardless of the wheel style, the spacers in behind on these bolts are going to give us just a little over 1 inch of clearance between the 2 wheels, so that inch and a quarter. All right. Now, the important thing about adjustments here is alignment first. We need to make sure that these wheels are equally spaced on either side of the seed trench. So if we take a look at the back side of the row unit, and we're looking through the back of this row unit, we have the pivot bolts are also eccentric bushings. These allow us with a pair of 3/4 wrenches to loosen up the locking bolt, and then we can take the eccentric bushing and we can move this whole assembly on either side and make sure that when we're in field position that seed trench is right down the center of that assembly. Okay, once we're comfortable with location, we can lock that in. And then we have a spring adjustment setting here too. We're going to consider it 5 adjustments. One is with no spring pressure, because in the event that we're using a cast iron wheel, those are approximately 55 pounds per row on their own without any additional spring pressure. We may not need any more than that. But as we look at these other adjustments, we can pick 1 through 4 to add spring pressure. How do we know what we need to do?
It's a good question, Phil. So it's going to be completely different based on soil conditions.
Correct. Environmental factors are going to be primary here, guys. We joke a lot of times about getting out of the cabin, working behind the planter, but it is truly important to get back here and dig. We can't assess closing wheel pressure by any other means other than getting out and digging. So as we do dig behind this planter and tool of choice, but as we're digging in that row, we're looking for signs of not enough, which could be open pockets or voids. We don't want any air around that seed. We want as close to 100% seed to soil contact as possible for that uniform germination. We also can get excessive. And if I'm digging down in the seed trench to find my seed and I'm picking out big clumps and chunks that are packed so tightly together, that seed may have great seed to soil contact, but is going to have a very difficult time emerging through that compaction layer. All right, so there's a fine line in there. So once again, the same recommendation as we did with the downforce, just enough to get the job done. Too little or too much on either side of that spectrum can be detrimental to emergence. All right, so those are your primary field adjustments and areas to watch for, things that we should be getting off the planter and looking at even as we change from farm to farm. Get a rain event, environment changes, take a look at your row units, make sure that settings and adjustments are correct for best or optimum performance. With that, thank you again for joining us on the Classic Planter Kinze Information series, and we'll start looking at meters next.